Okay, Vera, for this last exercise, it is the last one, right? Okay, this one I think is the most complete one. It's a good one. I have made some 5 more exercises for you about those in here, difficult ones, but we don't have time to go through them. But this one, it demands a little explanation first. So let me just build a track so we can understand what is going on. Let's take this wheel and let's make a mark in here. Okay? Let's start in here. Can you see? This is going to be the start point. Like this. This is going to be the start point. And I'm just going to, let me take a book, something. It can be this, I believe. No, it's okay. Let's be this one. I'm going to row in here, okay? Look, I'm just rolling. Oops, no, it. Okay, must row very carefully. Let's see. I hope it. Oh, amazing. Perfectly. It was a coincidence. And this is the end point. Of course, it might have slipped somewhere just doing this, okay? But this is going to be the end point. Okay, let's measure. This is 30, 1.5, okay? So this is about 31.5 centimeters. This is diameter, okay? This is symbol for diameter. The diameter is 31, I mean, not the diameter, but for diameter 1, let's call this diameter 1. So diameter 1, an arrow in here. Diameter 1, and what is 10? Okay, 10 centimeters. It is the diameter. Okay, I just measured 10 in here. Okay, 10 centimeters, and the circumference, it measures 31.5. Well, you're going to see later that to measure the circumference is just this, 2 pi times r. Pi, it is about 3.14, right? And the radius, it is just 5 centimeters. Let's bring up the calculator, because if you don't understand this, there is no point going on with this exercise. Okay, 2 times 3.14 times 5. Okay, we ended up very good results, 31.4 centimeters. This is the real measurement of the circumference. Okay, this is real, and this is experimental. What I'm saying is, this diameter, this 10 diameter wheel, when turns, it's going to go through a distance that it is equivalent to the circumference. Okay, look. Okay, it's okay. So when you say that the circumference, it is 30 centimeters, it means that once it performs a full cycle, it is going to get this distance. Now let's take this one. Let's see this one. hard to measure, but about 5.5, something like, yeah, about 5.5, okay, something like this. Okay, this is going to be hard to, let's take these points as a measurement, okay, and this is going to be our diameter 2, okay, diameter 2, diameter 2, can you see? Okay, it's going to be difficult to turn this one because I don't know how am I going to get. Let's try to take this book in here, maybe. Okay, it's 0, okay, I must touch, okay, I'm going to try to do, it is this one. Oh, no, it this one, right? It was this point in here. Yeah, something like this. It's slipped a little bit, okay? But let's see. And this is the end for this one, okay? And this diameter 2, it is about 5.5 centimeters. What is its circumference? Its circumference is going to be, according experimental, it is going to be about 17, okay? About, let's put it here, about 17 centimeters. Now let's go through the real data. Let's go using the formula. Circumference 1, circumference 2. It is 2 pi times the radius. 2 times 3.14 times the radius. The radius for this one is about half of this, right? Okay, the radius is just half. This is the diameter. The radius is going to be 8.5. So let's go to the calculator and let's just check. 2 times 3.14 times 8.5. All this. Let me see what is going on. No, of course not fair. The circumference is 17, of course. The radius, it is half of this, okay? Please. Okay, I'm terribly sorry. Okay, erase this one. The radius, it is 5. What is half of 5.5? 5.5 divided by 2. 2.75. Okay, the radius, it is just 5.5 divided by 2. This guy here, okay? Now let's do it again. 2 times 3.14 times 2.75. And this is, okay, wonderful. You see? 17.3 centimeters. This is real. Okay? The circumference, okay? And we measure on experimental. This is experimental. What is the meaning of all this, Vera? The meaning of this, it is this. The larger the wheel, the farther it goes. Okay? Oh, let me... Okay? The farther the wheel, the larger, right? The farther it goes. Because for one turn, look here, it is going to take longer. Okay? Now, if I picked a coin, very small, it would probably end in here, a little coin. No problems. So what I need you to understand from this is this is a preparation to understand the problem. Because we can't discuss the problem if you don't understand about this. The bigger the radius, the farther it goes. Or on the other way, you can think. If it has to go through the same distance, look, this one is going to turn what? Basically half, right? Okay, it needs more half. This one, up to this point, this second wheel was able to make a full turn. Remember? Full turn from here to here. The big one, it had just half turn. Look, the black dot is up there. And if I continue, okay, it's going to end here. So, one conclusion, it is this. Let's write here. Because if you don't understand this, there is no point even starting that exercise. The bigger the wheel, what is this? Oh, it's the end. The bigger the wheel, the farther it goes with one full cycle. Okay? The bigger the wheel, if we are considering one full cycle, meaning the black is going to here, is going to end here again, one full cycle, the farther it goes. That is why one full cycle of this is going to end in here. This is one conclusion. What is the other conclusion? To go along a certain distance, okay, the bigger wheel will turn less. Okay, because this turn one full cycle, this one just half. Okay, now I'm going to stop the video here. This is just the introduction to understand the problem. Okay, and on the next video I'm only going to explain the problem, and I'm going to consider that this is understandable. Okay, this is understood. What I need you to the next problem, it is this: the bigger the wheel, less turns it is going to make. Okay, and the explanation it is on that video.